Hi, this is Larry Watlington of Keep Cyber Simple. You know, one of the schools that I teach at California Baptist University, I taught a course called Information Systems Management. Great course. It was, believe it or not, this is in their business school. It's not so much an IT course or a cyber course, but it closely interleaves. And that's what motivated me to put this course together, because I got a lot of reviews from the YouTube channel and from the class where I posted some of the videos. So I decided then, okay, hey, you know what? Let's put this out here and let's make it a course. Again, Information Systems Management. This is just the introduction we're going to go into first, but then there's a series of training classes behind this. Okay, let's get into this. So when we talk about Information Systems Management, what are we really talking about? Well, it covers a lot of things. Now, throughout the expanse of this entire course, we're going to go into many of these areas in much more detail. And we're going to look at what it is information systems management within an organization. We're going to look at the DIKW model, maturity model, which is your data, information, knowledge, wisdom model. Some of the components of an information systems, and really some energy here on value chain and supply chain. Change management, really a big thing, and some of the careers available and some of the core competencies you will need as you pursue a career in as an ISM. All right, so if you've seen any of my courses, you know I always pretty much start out with the same slide. And I have to go here again. Something to consider when you're taking any type of training, whatever you're doing in life, this is something to consider, all right? People who know why will always tell people who know how what to do. Why is that important? Because many of the things I teach are at the grassroots, fundamental level, and I'm trying to instill not just the how, but the why. If you understand the why, it makes the how that much easier. Let me give you an example. All right, you see this? This is a representation of NFL football players. I think there's 32 here, one from every team. This picture's a little bit outdated. A lot of these guys are no longer in the league, right? But anyway, 32 players of professional players. And you know what they do? They know how to play football. They're good at it. They get paid to do it. However, you see these guys. These are NFL owners. They know the why. So in the business of football, who do you think makes the most money and who do you think has the most control? Players? No, they come and go. Owners? Oh yeah, they stay around for a while. These guys can strike every season, you know, they can. They want to go into contract negotiations, it doesn't matter, because at the end of the day, the ones who know why will always tell the ones who know how what to do. All right, so let's get into this. So when we think about information systems management, ISM, now you'll see I always love teaching in analogies, right? To me, this is very analogous to making shaved ice. You're like, what? Shaved ice? Yeah. All right, here's what I'm talking about. We have a customer. This young lad would love to have, in the summer, a cup of shaved ice, all right? But to make that happen, there are some things that has to transpire first. First of all, if you think about the key ingredient for shaved ice is what? Yes, water. So we have to get water from the city. We bring it in. And then a plumber, or a series of plumbers, you know, they're the ones who are responsible for taking that water and bringing it in. But at the same time, we want to be sure that the quality of that water is good. So that's what we have city water inspectors to do that. Now, that's very analogous to what we do within our IT and cyber departments, right? Our IT guys are responsible for our networks and getting information or data flowing throughout the network, reaching out to the internet, to the World Wide Web, getting us access. However, just like in this example, we also have security, like cybersecurity. By the way, that's my background, IT cybersecurity, who want to ensure that the data is safe, that it's confidential, that the integrity of the data is good, that the information and the data is available when someone needs to use it. These two entities in an organization have very similar skill sets, but different focus, okay? Not the same guy all the time. So now we got good water coming in, the water pressure's good, and the city water inspectors checked it out. And okay, now what do we do with it? Well, now we take it into some type of information system, right? Some type of production, some type of process. This is really what's key to any organization. If you are working with a business, and this is why that ISM degree many times fall under the business side of some schools instead of the CIS side, the excuse me, computer information system side of the house. Because now we're going to bring this water in, we're going to input it, it's going to go through some type of a process where we do what? Where we add value, the value stream. So, and what do I mean by that? Because now in this value stream process, this is where we're going to take some sugar, syrup, and we're going to add that to that ice that we've shaved, and now we've added value. What do I mean? And we sell that to this young customer, and he's happy. Now, if I offered this individual a cup of water and say, here's a cup of water, and I would like for you to pay me $2.50 for this cup of water, the little kid was like, no, I'm not going to do that. However, I can take just a little bit of shaved ice, add some syrup to it, some different color syrups, like the candy, cotton candy colors and all that. Now I offer that to the kid. Guess what? Oh, Mommy, Daddy, I got to have it. Why? Because we've added value. Now, and in organizations, our information systems are critical to this value stream. Likewise, information systems managers or management, those processes are very critical also. We can never forget, again, in this process, it's what? Risk. And that if you talk to any business, they are about mitigating risk, reducing risk to business, reducing risk to cost, so that now we can produce this product. We want to be sure that our water is safe. We want to reduce the risk of contaminated water. We want to reduce the risk of contaminated syrup that we add. Got it? So that's what information system is kind of like. Now let's take a look at this from a business perspective. Very similar model, right? So like I said, we've got our network devices and routers, switches, Wi-Fi, Ethernet, all of these techie components, again, that we are connecting up many times to the internet, to the World Wide Web, to other organizations, so that we can share data. Our cybersecurity, again, responsible for protecting that data, that information. Again, ensuring the confidentiality, the integrity, the availability of that information. And again, it goes into some type of value stream for that business, where we take the same thing. We take an input of information, data, or if you're in a industry that produces a product, same thing. Now we've got a production line. But if you think about most production lines and most production-oriented organizations now, businesses, they depend heavily on an information system or automation to produce something. So it's not just some guy in the basement bending metal anymore. Now you've got CNC, you got computer, digital design, all of these type things, computer numerical systems that rely heavily on our information systems. So these information systems are critical to, even if you're in factory type environments or just information management environments, of adding value, of supporting the value. So now when we have this small input, we add some type of value to a value chain, and then we provide that output, and there was where we should have successful outcomes based on our stakeholders. Many types of stakeholders, like I said, whether they're just buying the product, whether they are the board of directors, whoever it may be. So you see the value stream, the value doesn't change very much from making shaved ice to developing a product that we sell. You could be in the defense industry or wherever it may be. And again, at the center of all this is risk, and a big part of what you do is in that ISM environment is to show how to reduce risk, how to bring that risk down. So we think about information system components. All right, what is an information system at its grassroots level? Forget about technology for a minute and just think about it from this perspective. It's anything that can collect, process, store, disseminate, and also provide a feedback mechanism. Your public library. Really it is. It's an information system. Why? They can collect books, they process them. They used to use what we call the Dewey Decimal System. They don't do that anymore. That's just old guys. But that's how they would process and store books on a shelf, and they're able to disseminate those books. You can go there and check a book out, and they will disseminate, and a feedback mechanism to monitor operation. Yes, they have controls in place to say how efficient are we at collecting, processing, storing, and disseminating books. And this could all be done manual. It was done manually for years, hundreds of years, right? So when we hear of an information system, don't always automatically think that we're talking about a digital information system. It can be a manual process as well. But for the purpose of this class, yeah, we're typically talking now about information systems that are digital in nature. So what's the components? hardware, software, networks, procedures, and people. These are 4 things. If you're going to a college, if you're taking a course on information system management, these are the bedrock components. Drill these, paste them on your forehead. Hardware, software, networks, procedures, people. All right, let's talk about each one of these just briefly. So when we're talking hardware, we're talking like your data center. This is where information is processed, is stored, as well as how it's prepared to go across the network. Networks, again, it could be anything from routers, switches, Wi-Fi, you name it, all types of networks we have. And the software sits on top of hardware, and this is how we process information using the software. Now, those are the technical parts. These 3 are the technical parts of your network. Many times, this is where we stop, because we spend a lot of energy here. This is the money. This is where we spend money buying new hardware, new computers, storage devices, the latest and greatest software, updating our back-end networks, and many times where do we fall short? Right here, these last 2. Processes, procedures, and the people, okay? Always remember, your network is only as good as the underlying administrative processes and the training and the core skills and competencies that the people who manage this network brings to the table. Hardware, software, networks, procedures, processes, procedures, people. Now, what else we can do? When we look at information systems, we can break them up into basically 3 types. You've got personal information systems like what you had at home. I'm sitting here looking at my information systems. I got computers and monitors all over the place. You can have a group for collaboration among members within a work group. Now, those personal information systems, again, and even in the workplace, not just at home, are the ones that's sitting on your desk many times. It could be, or your BYOB, bring your own device, your cell phone, personal cell phone groups. And then you have enterprise. At the enterprise, those are used to define, the interaction among employees, suppliers, internal stakeholders, external stakeholders. Make sense? All right, let's move on. So we've talked about the information systems a lot, but at the key of an information system is really the data. That's what this really comes down to. Do people care about hard drives and software and computers and routers and switches? Yeah, we do. Why? Because they are the means to either process, store, disseminate data. So it always comes back to the data. Now, when we think about data, what is it? A collection of raw facts from which conclusions can be drawn. That's data. Data by itself, is meaningless until we are able to draw some type of conclusion from that. Now, data is converted today in our environment to a more convenient form called digital data, right? So we take things like movies, photos, books, letters, all these things. Now we have a means through technology to convert these to some type of a digital format. Like that. Most of our movies now are digital. Most of us probably don't have a VCR in our home anymore, where you've got analog films. Same with photos. Nearly all of our photos are digital. I haven't seen a film processing camera in several years, as well as books. We've gone to ebooks. Letters, yeah, we've lost that art of writing letters, and now everything is email. I hate that we've lost that art, because there's so much I think we've lost societally, but that's a subject for another day. Now, we know this is going to grow, right? So what are some of the factors that support the growth of digital data? Well, one thing, we've been able to increase the processing power and the capability. So now we can process and store so much more data than we could in a manual format. We can take an entire library of hard copy books and put that basically on a thumb drive that big. So now that's increased. The cost of storage, again, like I say, talking about, now do I need rooms and rooms and rooms and buildings of archived paper? No, I can store that stuff on a server, on a hard drive the size of my hand. And we can move that data faster, because now if I want to get you a book to you, I've got to mail it. There's a lot of touch points. Ebook, wow, just jump on the computer, pop it open, and I can get access to it. The same with email and things like that. So that is when we look at data, now how we've converted that data. Now let's look at the types of data. Basically 2 types, really 2 types of data, or 2 classifications. It could be structured or unstructured. And you say, well, what's the difference? Good question. I'm going to tell you. So when we look at data, structured data is this little wedge right here. that's data that's in like a database, where you've got rows and columns and tuples or cells, and you put data within those databases. About maybe, 10 to 20% of the data we have now is actually structured. Most of the data that we have, that we look at, is unstructured. When I talk about unstructured, that's like the ones and zeros associated with video. Video is unstructured data. MP3s, unstructured data. Emails that we send back and forth, documents, all of that stuff, it is unstructured. And the fact that it is just a mass of ones and zeros that are sitting on your hard drives, on your computer. To make sense of unstructured data, we need structured data. You need some type of database. You need some type of organized way of accessing that data. Give you an example. You look at your home computer. Let's say you're a Windows guy. You have File Explorer on your computer. Why? Because it shows you all the folders. It gives you a structured way to see all the data that's on your computer. If you didn't have a structured way to do that, it would just be, a mass of information. It's almost like going into the New York City library, and they didn't have labels, they didn't have an indexing system, and you just saw rows and rows and rows of hundreds and hundreds of books. You would just, and you wanted to find something. It would be totally frustrating because that would be unstructured. Now, when they put the labels and indexes and they have a database you can search, that's the structured part of data. Two classifications, structured and unstructured. Now, a term you hear more and more as the amount of data grows is called big data. I know now we talk about artificial intelligence and machine learning. Yeah, those are two areas that are exploding. You go on YouTube now, you go places, and Chat GPT. You've got people making songs, that sounds like Drake and other artists, and no, they're using AI to generate those things. Now, are there legal, things associated with that? Yes, there are legal concerns. But anyway, but it takes this thing we call big data, and big data are, like I say, it's data sets whose sizes are beyond the ability of commonly used software tools to capture, store, manage, and process that. Let me give you an example. YouTube. It's estimated that YouTube, now, I have a hard time wrapping my head around this number. They have 1 exabyte. Exabyte. And what is an exabyte? That is 1 million terabytes of storage space in its data centers. Now, if you think about the amount of video that's uploaded to YouTube constantly, daily, for instance, like this course, I'm shooting video right now that's going to be what? Uploaded to YouTube. So to put this into maybe perspective, okay, for a long time we were talking about, megabytes. When we first started talking about computers. Think of, megabyte as having, excuse me, $1 million. A millionaire. Now, then with technology, we were able to move up to gigabytes, which is, think now about being the difference between a millionaire and a billionaire. Big difference. Big difference. We have a lot of millionaires out there, but that starts stratifying. Now we're going to talk about terabytes. Think now about a trillionaire. Okay? Trillionaire. Think about how the money difference that we're talking about between them. When they talk about the debt ceiling, we got $1 trillion debt limit. That's huge. I can't wrap my mind around that. And that would be proportional to terabytes. Now, an exabyte is 1 million terabytes. So, I don't even know how to state that. So you see the size that our data stores and data things are growing. That's why you have to have different types of software and tools to be able to manage this thing called big data. Now, later on in the course, we're going to talk a little bit more about some of these tools, Hadoop and some of the different tools that are used to manage large data sets. Like I say, big data analysis real time requires new techniques. High performance hardware, high performance applications, high performance software, and now we're getting more into what we call MPP, or massively parallel processing data platforms. So now instead of one computer that does not have the capacity, or even a server, or even a data center, now we're able to process in parallel multiple data centers to be able to process the amount of data that's being generated. But what does it help us to do? As we're now able to carve through some of this big data, it helps us now to do things that many of us don't like. Such as, now you go on the internet and you search for something, and now the next time you open it up, you get all these ads of what you just searched. Why? Because they are, with big data, analyzing and looking at our data, our shopping patterns, our search pattern, all of the data, all of our digital footprint is being collected, analyzed, and now used as a tool to influence our shopping habits, our day-to-day life habits. But that's what, just a snapshot when we talk about big data. Now, this DIKW model, this is very interesting because this is really how we process data. Data, information, knowledge, wisdom. All right, so what I have here is a book, right? Actually, it's a Bible. I read a lot, which I read a lot. But if I take that book and just look at it face value, what is it? It's a bunch of symbols. It's just data. If I just open it up to a page, it is just a bunch of symbols on a piece of paper. And that's what that's all data is, until someone picks it up and ingests it and read it. So when I just read, a chapter out of this book, I've ingested that. So I've taken in some information. Wow, that's good to know. Well, what does it really mean? Not that much until I start to digest it. Now, when I digest this starts to become knowledge. Now I know something. Okay, it's not just information that's just, okay, that's of random facts that I read. Now I've digested this and it's become knowledge and I've internalized that. However, is that really where we want to stop at? No. This is really where we all want to get to. It's where now I can apply that information. So now it becomes wisdom and understanding. And now I can make decision quality, information-based decisions, on the data that I've ingested, that I've digested, and now I'm getting ready to go out and apply that. So this is really, as an ISM, Information System Manager, is what you really want to do. We live here many times in this data information area because this is where our information systems are. But really where we want to do, and this is where things like big data, data scientists, is now how can we make it easier to digest this knowledge and to be able to apply it within your organization, okay? Because here's what happens in many organizations that we have got to get better at. You have someone who's been there 15 years, and they are a linchpin to the organization. They retire. Look at how much intellectual property, how much knowledge walks out of the door that haven't been harvested off from that individual because we don't have the right information systems in place to be able to pull and extract and capture. We use wikis, we use websites, we use things like that, but they still are not at the level of efficiency to be able to capture the knowledge that someone who got 15, 20, 25 years of experience, and be able to capture that so that someone else can ingest it and digest it. Now, we talked about this earlier, value chain. I'm just going to put up a couple of definitions so we can understand it. Because at the end of the day, your information system is there to provide value to your organization, right? So let's take some definitions. What is the value chain? It's a series or a chain of events or activities that an organization performs to transform inputs into outputs, just like the shaved ice. We took in a raw material, added some sugar water to it, we increased its value, and now we sold that. So what is the supply chain? The supply chain, like I said, that's the key value chain in a manufacturing organization. Just like we talked about with the shaved ice supply chain, we had to get water in. So that was part of the supply chain. Get it from an external source, from an external stakeholder. Then we have to move it internally through internal stakeholders to get it into that manufacturing or that production process. And a big part of supply chain is just this, supply chain management. Like I said, this is all the activities required to get the right product to the right customer's hand in the right quantity at the right time at the right cost. You see, there's a lot of moving pieces in this. Now, a part of this supply chain that's becoming more and more critical today from an information system perspective is the cyber aspect of your supply chain. Okay, so now you're bringing in information system parts. How do you know where those parts are coming from? How do you know where these components are coming from? The cyber security surety of these. Were they made in a country that because I work for the government. I've been in the military, and we've had instances where we found microphones and other types of nefarious components inside of keyboards and mouse and things like that. So understanding the cyber aspect of your supply chain is critical as well. So like I said, your information system is critical to this supply chain process. Why? Because it provides all your inputs, it aids in product transformation, provides output, and it adds value or profit to your process. Now, within an organization, one of the things as an ISM in this environment you have to deal with is change. Why? Because information and information systems, they change quite often. So change management is very key. So you just can't be a techie guy and go, yes, I know the techie stuff, but and not understand the people side. Having a great IQ is important, but your intellectual quotient, but your emotional quotient, your EQ as well, is very important. So change is necessary for growth, future success. We can't stay stagnant. Now, there's many models that we could talk about. One of the models that is relatively prevalent is a 3-stage approach called the Lewin's change model. This is where you unfreeze, move, refreeze. What is that talking about? Unfreezing, this is when you start preparing for a change. And preparing for that change during this unfreeze process, it's going to encompass all those components of the information system, hardware, software, network, procedures, and people. You have to unfreeze all of those many times. Okay? And unfreezing, can be sometimes very stressful within an organization. Why? Because we've gotten used to being frozen. We've gotten used to being in one set way. And oh my God, now we're going to have to change states. Think about it, just like water and ice. Ice has been in this state for a while. Now you're asking me, and to change states, just like with water, if I'm going to change states of water from ice to water or from water to steam, what do I have to apply? Heat. I've got to apply something to make it move. And I've got to agitate many times those little molecules, to get them to start moving faster to change the states. In this unfreezing process, the same thing. You've got to many times agitate just a little bit to get people to break from what they know. The hardest part about getting a new idea in is getting the old idea out. This is all part of that unfreezing process where you're preparing for change. So you got to remember, you're also not only preparing the technical side of the information system, but you have to prepare the unfreeze processes, procedures, and the cultural mindset of the people that you're going to deal with. Now that you've done that, now you're going to the moving phase. This is where you actually start making the change. Okay, now many times if you've done a great job at unfreezing, it makes the moving that much easier because you've already got people on board. They've bought into the change, and now you're ready to move forward. Once the change is made, now it's time to refreeze because you want to lock it down, institutionalize your processes, your procedures, your standard operating procedures, all those things. You want to get those things locked down and refreeze. Now, this is just from some personal experiences, okay? As I've had to deal with change management, again, 26 years in the military and Air Force, worked in industry, I've worked for the government as a civilian, as a contractor rather, in a lot of capacities, as well as in the civilian sector where we are today. So one of the things you have to develop is a sense of urgency. Why? Because everybody's going to ask the question, why are we doing this? And if there's no urgency, they will drag it out and it won't get done. So you have to produce a sense of urgency. But urgency not just for the sake of urgency for the sake of this is going to be better for everyone. So, and we need to get this, to get it done so that now we can move into this new way of operating. Now, someone has to have a vision and there has to be a strategy. Change just for the sake of change is not good. So there has to be a leader, not just a manager, a leader. And remember, you lead people. You manage resources, okay? So you need to have, we need to have both of them. Many times have both of those hats on, your leadership hat and your management hat. We love to grow great managers. Sometimes we are faulty at growing good leaders. So someone has to have a vision and a strategy so that everybody can see the vision, write it down, make the vision clear. Whether it's in PowerPoint, whether it's in Jira, whatever tools you want to use, but people have to understand the vision. And then at that point, you start doing three things: communicate, communicate, communicate. And many times you have to communicate from multiple directions. It's always great and to start at the top-down communication, so that they know that this isn't just some good idea fairy who came up with this, but no, this is an organizational change, top-down, communicate that. Lateral communication from one inter-organizational alignment with another, at the peer level, and then bottom-up communicate. Listen to what the people below you and from the sides are saying, because many times we miss that side of communication. Empower and include. Yes, empower people to help you make the change. Everybody typically wants to be a part, feel like they're a part of the organization. Include them in. Listen to everyone's ideas. And then I think something that's critical, embrace short-term wins, okay? Okay, we've got several things we need to do. We got this done, great, High five in the hallway. All right. However, don't get stuck on just short-term wins. Still, you want to strive for long-term successes. It's the difference between it's like winning the battle, great, but we want to win the war. To win the war, we got to focus on battles. However, to stay focused on that battle, we need to know what success looks like at the end. So that is just some things in my personal life and work life as far as change management. So when we think about some of the core competencies that's required for this ISM environment, basic networking. Yeah, it helps to have some core skills in switching, routing, firewalls, layer 1, layer 2, the OSI model. Now, do you have to be a networking guru? No, you don't. But you definitely want to have some background, some core competencies and skills in those areas. Likewise, at the operating system or application layer, be very knowledgeable, cognizant of whether you're in a Windows environment, if you're in a Linux environment or a Mac OS environment, have an understanding. Now, do you need to be a system administrator? No. However, you need to understand what that system administrator does and what the impacts of making changes to that operating system or to those applications will make. Many things in most businesses now are moving to the cloud. So understanding cloud concepts is paramount. Whether it's the your cloud models, software as a service, platform as a service, infrastructure as a service, that SPI model, or the business of cloud. Moving to cloud, okay, and I think really this is more so than understanding the technology, understanding the business case, because cloud is a business model, right? It's a service delivery model. So understanding that, moving things to cloud, it may sound cool, may sound sexy. However, long term, it may not be cheaper. If you don't understand the service level agreements that you have, and do you still own your data, your information? All those things are things to be aware of in the cloud environment. Have an awareness of cryptography, because this is how we protect our information systems for the most part, is with encryption, or the data that resides there. As well as, understand scripting. Why? Because a lot of things that's going to happen in your environment are done automatically. We have different types of software now that, like Ansible and other tools, that we can do a lot of automation. This is where we're trying to move to more and more, is how do you automate processes instead of having, an individual sit there and do boring, repetitious tasks every day. How do you automate that? And a lot of that automation happens through scripts, whether it's PowerShell, Bash, Splunk scripting, whatever it may be. We talked about data, right, and databases with structured and unstructured. Well, if you are going to live in this world, having a solid foundation and grasp of database concepts is paramount, because many of the things that we do, we are managing unstructured data in structured data formats. And some basic programming skills. Again, not saying you got to be a dyed-in-the-wool energy drinking, computer programmer. However, having a basic understanding of Java, Python, C++, some of these things is good. So those are some core competencies that I definitely recommend that you look at as you are going through your course, whatever it may be, so that you can become better at what you do. Now, what type of IS careers tie into information systems management? Everything from customer support, these are your help desk type skill sets, systems analysts, as well as software application analysts, developers, whether they're web developers, application developers, computer programming, you got database analysts, and we know about cybersecurity, networking, cloud development. All of these different things go into actually some of the careers that you will work with or a part of your IS management team that you will have to reach out to daily. So that's why it's good to have an idea of what do these individuals do. Because if you are an information systems manager in an organization, you will have to be able to talk to and coordinate and collaborate with many times individuals who bring these common core skill sets to the table. Being able to speak their language is critical. All right, so what have we done? Like I said, we really talked about the information systems management, just overview, and now we're going to go deeper into some of these areas. Stay tuned for the next part.